Hello everyone. So today we'll be talking about one of the ways to solve differential equation, that is the linear form. We are going to change the differential equation into the linear form and then you're going to solve it. Forgive me if my handwriting is not that great, but then I'll try to explain everything that's needed as far as I can. So first of all, the first way would be to change it in the form of dy over dx plus y is equal to qx. So what I'm saying is dy upon dx will have coefficient as 1, that's a compulsion, and then there will be a term containing y, and this will be the coefficient, p will be the coefficient, and then there on the right hand side there will be a term containing x, and then its coefficient will be q. And similarly, if you want to express it in the form of dx over, wait a minute, let's write x, yes, dx over dy, then it's just going to be the opposite. So px, x will be over here, and over there you'll have qy. So this is the standard form. So after this, how you will be solving is you're going to convert whatever the question is in this standard form, either this first one or the second one, whichever is appropriate. So by appropriate, I mean that you're going to try and make the coefficient of dy over dx or dx over dy 1. That's a necessity. And then we get to learn about something known as the integrating factor, or let's say if. So what if is if is equal to e to the power integration of p dx, or if in the other condition it would be p dy, so if p is expressed in the term of x, then it would be dx or else dy. So it can either be this or p dy. I'm going to give examples so that you understand it even better. So after finding the integrating factor, then you're going to multiply the integrating factor with the standard form, that is either for the first one or the second one. So it multiplies the standard form so, and finally what you will be getting is, if you multiply the integrating factor with the standard form, you will be getting something as, d, if you express it in the form of dy over dx, then y times integrating factor. I'm going to tell you how we got this, over dx is equal to something something something. So it's a little bit complicated than the other ones, like variable separation, as you have to deal with integrating factor and then take the standard form and so on. But then let me give you an example so that things get way clearer. So let's take an example. So dy over dx, I think there are helicopters hovering, so I think that's not a very big distraction, but then let's continue. So is equal to e to the power 3x. So this is our first example. I think it's the easiest one. So let's see, it is in the form of dy over dx, so our first criteria is met. The coefficient is 1, so the first criteria is met. The second criteria is, in the standard form. Is it in the standard form? So dy over dx plus py is equal to qx. So we have x on the right hand side, y over here, and it's in the form of dy over dx. So yes, this in fact is in the standard form. So now we've already converted it into the standard form, so we don't have to do anything else. Now what we might have to do is find the integrating factor. So over here 2 is the is comparable to p. So the integrating factor that we need to find is p dx, integration of p with respect to dx. If it were to be dx over dy, then it would be p dy. So what is p? It's 2. So let's integrate 2. And what is the integration? It is simple, 2x. So this is the integrating factor. Now what I had told you was to multiply the integrating factor with the standard form, which is the given equation. That's the one we've been dealing with. Let's just change the color. So now you multiply the integrating factor. So integrating factor is, wait a minute. So integrating factor is e to the power p dx, not just p dx, This is just the first step. So the final integrating factor is e to the power 2x. I hope you're getting that. Wait a minute, I'll go back over here. So yes, I've told you that integrating factor is e to the power p dx, and here e to the power p dx. So e p dx is 2, so the integrating factor is e2x. So now let's solve the question. So we multiply e2x. So e2x multiplies dy over dx plus 2y. It multiplies the right hand side as well. And I hope that you know that whenever there is the same base, then we can just add the powers. We have the same base, so it's going to be e to the power 5x. It's the laws of indices. And then what next? Yes, and one more thing. If, wait a minute, I'll show it to you so that you understand it. I'm going to do something that might be a little baffling. You might not understand it in the beginning, but then I'm sure you'll get it afterwards. This, it's kind of like a shortcut that you might want to remember while solving questions like these. So what I did is, if you want to find the derivative of this entire, oh wait, I'm using the eraser. What I wanted to use was, wait a minute, I think I ruined it. So what I was trying to do was this, dy over dx plus 2y. Yes, this was what we had. So what I meant was y times e to the power 2x over dx is equal to e to the power 5x. So I was telling that this is a shortcut. So if you are to find the derivative of this entire term using the product rule, then you would get whatever is in this term. You would get exactly that. If you want to try it out, you can do it, but then I won't be doing it since it makes the process entirely lengthy. But then you can try it on your own. If you are to find the derivative of this, then you would be getting this. So instead of this term, what I'm getting, I'm still getting used to this, so I think I'm making a little bit of mistakes, but anyways, yes. So if you are to find the derivative of this term, then you will be getting entirely this, exactly that term. So yes, now let's go to the next page, remembering that we found this at the end. So finally, what you can do is you can send the dx to the other side. So what I mean is y e to the power 2x is equal to e to the power 5x times dx. And now that we have this, let's just integrate both the sides. And I hope you know that integration and derivative are just antagonistic in nature, or rather, let's say opposite in nature. So integration is just antiderivative, so their effect cancels each other out. So from this we get y times e to the power 2x is equal to e to the power 5x over 5 plus c. This is simple integration. This is the simple integral. So finally you can express the final answer as, therefore, y times e to the power 2x minus e to the power 5x over 5 minus c is equal to 0. So yes, this is the final answer to this question. It's a little bit confusing than the rest. It's not very similar to variable separation. So I'll be making a few videos solving questions related to this, so you don't have to worry about it. It was just an introduction to linear differential equations. So questions that are not usually solved using the methods of variable separation are solved by this method. So all you have to take care of is to try and make the coefficient of dy over dx or dx over dy as 1, and then make sure that if it is dy over dx, then y is on the left hand side and term containing x is on the right hand side, and then find the integrating factor. And then integrating factor is of course e to the power integration of p dx or p dy, and then multiply the standard equation with the integrating factor, and then remember about the product rule that makes our solving process simpler. As you go on to solve questions, you don't have to really show that it came through the product rule. You can directly understand that if we have expressed it in the form of dy over dx, then it is obviously going to be d, and in the bracket y and whatever the integrating factor is. And yes, I think that's all that you need to know. Any more confusions? No, yeah, I don't think so. And then yes, of course, you have to send dx to the other side and integrate both the sides, and then it's simple integration. And yes, of course, one more thing, the effect of integration and derivative gets cancelled out when they come together. So yes, that's another thing to be taken care of. Rest, I think you have already understood. And yes, thank you for joining with me, and make sure to check out the videos that I'll be posting on this topic. Thank you.